Hello students, how are you? I hope you all are doing well. So in the last 4 lectures of light, we have covered the topic reflection of light. And at the initial classes, I had I can say in the first class, I had a discussion of two properties of light. One is reflection and another is refraction. So in reflection part we have covered in last 4 lecture. Now we will go for the refraction of the light. So have you experienced this experiment, or you can do that if you have not experienced it. Take a glass and put some water, okay, and put a spoon inside that water glass, and you will see at the water level, at the starting of the water level, and if you see from the side, you will find that the spoon is look like spoon is broken. But if you take out the spoon, it will be as usual. It will not broken. It is still the same spoon. So why is this happening? Okay, so it is because of refraction, and we will discuss in detail of this refraction part. So before that, let us have a video. I have a video to show you. Just see that video, and after that we will discuss in detail about the refraction of light.
I want to swim, but I'm scared. I don't know how deep this pool is.
Hold on. Let's use this stick to check the depth of the pool. Can you see that its length is bigger than you?
Let's put it in the pool.
Okay. See? Half of the stick is outside, so you can go inside. It's not very deep.
But look, Jenny, the stick looks bent.
Yes, that is not bent. This looks bent due to refraction of light.
Refraction? Oh, you told me about reflection, but you never said anything about refraction. What is refraction?
You know, when light travels from one medium to another, it bends.
Like when it moves from air to water, one medium to another?
Yes, air is one type of medium and water is another type of medium.
Hey, even your hand looks bent.
Yes, and now you know that it seems bent due to refraction of light.
But why does light refract?
For that, you first need to enter the pool.
But why?
Go on, young man. To learn something, you need to do something.
Okay. This water is so cold. I want to come out.
Okay, but before you come out, try to run for some distance in the water.
I can't run faster. This water is stopping me.
Ah, darling. Now come out. Let's go home and learn more about refraction. So, Jimmy, you could not run fast in water, correct?
Yeah, I can run much faster otherwise.
Let's see. Why could you not run fast in water? You know, water is more dense than air. You have to run against air while on ground. But your speed is less in water because the water is denser than air.
So, same thing happens to the light. When it enters water from air, its speed becomes less and its direction changes.
Let's do one more experiment to understand it more. Put this pencil in this glass of water.
Wow, this also looks bent.
But we know for the fact that pencil is actually not bent. It is refraction. Let's look at it in the details. See, the light reaching the eye is coming from a different direction.
Yeah, because light changes its direction when it travels from air to water.
Yes, it enters from one medium to another. So it changes direction due to difference in density of the two mediums. This is refraction.
So guys, now you understand refraction. Now, time for some homework.
It is easy.
Okay, your homework is to take a pencil and put it in a glass of water.
And remember that the bending of the pencil is due to refraction.
And your second homework, my friends, please press the like button below. Thank you.
Okay, so I hope you enjoyed that video. Okay, it's a lot of things discussed about the reflection with for example, and some beautiful examples, not great example, those are beautiful examples. Okay, and thanks to you can say makemegenius.com for providing this video. Now let us we'll discuss in detail about the application. Let us first discuss what are the content we are going to discuss about in the refraction part. So in the refraction part we'll discuss what is refraction, and then laws of refraction, like the same. We'll follow the same path that we have followed for the reflection. So what is refraction, and laws of refraction, and what is refractive index, and what is the refraction of light by means how the light travels due to refraction in spherical lens, and all those things we'll discuss. But in today's lecture we'll discuss only about the first three parts, that is what is refraction and laws of refraction and then refractive index. In other lecture we'll discuss about, next lectures we will discuss about the remaining part. Okay, so what is refraction? So when light travels obliquely from one transparent medium into another, it gets bent. Okay, this bending of light is called refraction of light. Like see, in the first lecture, remember in the first lecture I had told that light travels in a straight line, provided it travels in one medium. Okay, what is medium? Medium is like air, water, glass, all those transparent parts, those are called medium. Okay, so in each part the light have a constant speed. Okay, so light have constant speed. In air it has a, suppose it is speed is v1, in water it will be v2, and in glass it will be v3. So light have different speed in different medium, but that speed is constant in a given medium. Now when light travels from one medium to another medium, suppose it travels from glass to water, or air to glass, or air to water, what happens? It gets bent. Okay, because of change in speed. I will discuss in detail. So because of change in speed, light gets bent, and this part, this bending of light is called refraction of light. Okay. When light, and second point, when light travels from rare medium to denser medium, it bends towards the normal. See, what is normal? In the reflection part I have told, that is you have a plane where the light strikes, and at that point, and there is a normal to that plane. So that plane, here also there is a plane in the medium. And when the light travels from rare medium to denser medium, light will travel towards the normal. Light will bend towards the normal. If it is going from the denser medium to the rarer medium, then it will move away from the normal, or it will bend away from the normal. Okay, these are the three properties of refraction, like what is refraction, and what happens to the light when it moves from rarer medium to denser medium, or denser medium to the rarer medium. Now next, what is refraction, that we are discussing here with the diagram I am showing. Suppose this is the rarer medium. Okay, let the rarer medium is air, and the denser medium is water. So in the rarer medium, see, there is a line where the light will strike. Okay, that is, you can say, the barrier between the denser medium and the rarer medium, or is the meeting point of two medium. Okay, meeting line of the two medium. So at that point, there will be normal. So normal means here there will be 90 degrees, right? Let me have the plane now. Okay. So here the angle is 90 degrees. Okay. So now light will light is coming, light is traveling in the rarer medium. See, the light is traveling in the rare medium and strike at this point. Now, from when it enters the denser medium, what happens? It is going from the rare medium to denser medium, so it will move towards the normal. See, we are supposed to move in this direction. So it will follow the same direction. But what happens due to refraction? It will see this was the expected path, because this is the path of the light. Okay, because I have said you that in the first class, light never changes its direction when it moves in one medium only. So now we are expecting the light travels in this step line, but it changes the medium. Now it is going from rarer medium to denser medium. So what is happening? Now the light is moving towards the normal. So this is the light. This is the path of the light in the denser medium. Similarly, in the case of when light travels from denser medium to rarer medium, now instead of following the same path, light is moving away from the normal. Okay, so here you can see there is the angle between the normal and the refracted light is smaller when the light is traveling from rarer medium to denser medium, and here the angle is higher. Now next, what happens when the light travels through a glass slab? Okay, now see, this is the incident light, and this is the glass. So when light travels from air to glass and then glass to air, because this is the rectangular slab. If this is the rectangular, suppose this is your glass. Okay, now light travels from air, and this is transparent. So light travels from through the glass and then coming out from the glass. So there are three things. When the light travels from the air, it will be incident ray, and when it is traveling through the glass, it will be refracted ray, and when the light is coming away from the glass, coming out of the glass, then it is called the emerging ray. Okay, that is the emergent ray. So you can see three terms. This is the incident ray, then refracted ray, then emergent ray. Okay. Now see, glass is always denser than the air. So this is the normal. Now the light is what will be the path of the light when it is traveling from the air to glass to air again. So this is the normal, and this is the incident, angle of incident. This is the incident ray. Now since it is next part is this is the denser medium. This is the glass, and this is the denser medium, and this is the normal. Then we are expecting the light to travel, to bend towards the normal. So the angle of refraction, that R, is now smaller. Now is this point. Okay, the light is traveling or bent towards the normal. Now when it travels through the glass and now coming out of the glass, since it was traveling inside the glass, and now entering the air, that means it is going from denser medium to rarer medium. So that means it will go away from the normal, it will bend away from the normal. So you can see this is the normal. Okay, and this is the angle of you can say this way we are expecting this path to follow, but the light is traveling away from the normal because it is going from the rarer medium to denser medium to rarer medium. Okay. And now the distance between the incident ray, and the emergent ray, because this is the initial light and this is the final light. Okay. Now this distance, you can see, this is called the displacement. This is the displacement, and this angle called the angle of emergence. Okay, now if you understand this part, you can understand the reflection part, because here we are talking about two change in the medium. One is when case one, when the light travels from air to glass, and second when the light traveling from glass to air. Okay, now the laws of refraction of light. The first law says the incident ray, the refracted ray, and the normal. I have told you what is the incident ray, what is the reflected ray. Like here, this is your incident ray. This is your incident ray. This is your reflected ray. Refracted ray, and this is angle of refraction, and this is your angle of incident. Okay. Now and another term is normal. This is normal. So what is the first law of refraction says? The first law says the incident ray, the refracted ray, and the normal to the interface of two transparent medium at the point of incident all lie in the same plane. The same case as we have discussed in the reflection part. If you remember the law of reflection, I have told that the incident ray, the reflected ray, the incident ray, the reflected ray, and the normal all lies in the same plane at the point of incident. Similarly, in the case of refraction, the incident ray, the refracted ray, and the normal to the interface all lie in the same plane. Okay, and the second law says the ratio of the sine of the angle of the incident to the sine angle of the refraction is a constant for the light of a given color and for a given pair of medium. That means suppose if you have this is the medium, this is air. Suppose this is air and this is glass. Okay, this is glass. Now this is normal, this is incident ray, and this is refracted ray. So this is your angle of incident, I. Okay, and this is your angle of refraction, R. Now this sine I upon sine R, which is constant for a given. If it is air, if it is glass, and the light color is constant, then at any time the angle sin I by sin R will be constant, and this constant value is called refractive index. This constant value is called refractive index, and this refractive index will decide the speed of the light in different medium. And the refractive index is constant for a constant medium. So suppose if I compare with air to the glass or air to the water, then air to the glass is always, the refractive index is always constant. Yeah. And similarly air to glass, the refractive index will be always constant. Similarly the refractive index for when you take water to glass, or that is always constant. Okay, so refractive index is always constant for a given two medium, and this particular second law is called Snell's law of refraction. Sometimes you may be asked in the exam that what are the laws of refraction, or sometimes you may be asked define Snell's law. So Snell's law is nothing but the second law of refraction. Now, what is as I have told, what is the refractive index? The absolute that constant is called the refractive index. We have discussed. Now, if we discuss in detail, the absolute refractive index of a medium is the ratio of the speed light in air or vacuum to the speed of the light in medium. But we believe that we consider the refractive index of air as 1, means with respect to air. So refractive, and whenever we compare any medium, we take the air as the reference. So whenever we discuss about the refractive index, if we know the refractive index of one medium with respect to air, then and another medium with respect to air, then we can find the refractive index of refractive index due to those two medium. Okay, so what is refractive index? Refractive index speed of light in vacuum or air, that is C, generally denoted as C, and speed of light in the medium. Okay, so eta is equal to, eta is the symbol of refractive index, and this is the speed of the light. As I have told, the refractive index decides the speed of the light. So eta is equal to C upon V. So if you talk about two medium, so refractive index of medium 2 with respect to medium 1 is the ratio of the speed of the light in medium 1 to the speed of light in medium 2. How? See, if I can say, let us consider eta 21 is speed of light in medium 1 to speed of light in medium 2, and V1 upon V2, eta 1 2 is V2 upon V1. Like, see, suppose I consider air. So eta 1, what is eta 1? I will say eta 1 is equal to, it will be C upon V1, right? C upon V1. What will be eta 2? What will be eta 2? Eta 2 will be C upon V2. Now, if I find the ratio of eta 1 upon eta 2, then it will be V2 upon V1. It will be V2 upon V1, and this is called eta 1 1 2. Okay. Now, based on this, you will get some question. You may get some question in the exam. Okay. So here are some questions this question were already asked in previous exam. So try to solve this question. Start to answer this question. If you find any difficulty, then let me know. I will help. Okay. So bye bye. We'll see you in the next class.